Today we're going to learn about scientific notation. Scientific notation is a different way of writing really large numbers into a more simplified version in order to make reading the numbers a little bit clearer. Powers of 10 are simply multiples of 10. So 10 times 10 would be equal to 10 squared. And similarly, 10 times 10 times 10 times 10 times 10, for example, is 10 to the fourth. The exponent describes how many multiples of 10 there are. Now, we also know about decimals. And for decimals, moving the decimal point to the right by one digit is equivalent of multiplying by 10. And moving the decimal point 1 to the left is equivalent to dividing by 10. So when it comes to standard notation, we want to take extremely large digited numbers and reduce it into smaller form factor. Now, using the property I just showed you, scientific notation is described as a term which is in between 1 to 10 and another term which is going to be a power of 10. So I'll get into our first example to show you what I mean. Now, for this first example, if we move the decimal point 1, 2, 3, 4 places, you'll notice that we'll have 1.4. 1.4 is in between 1 and 10. So the first term is complete. Now we know that this number here, 0.00014, is not equivalent to 1.4. So we're going to multiply it by a power of 10. How many times do we move the decimal point to the right? We moved it 4 times. Now you might think that we raised it to the fourth power, but that wouldn't make sense because if that was the case, then the decimal point would be moved 1, 2, 3, 4 times, and the number should be 14,000, but it's not 14,000, it's 0.00014. So what we're doing here is taking 1.4 and moving the decimal point backwards 4 times. So this is going to be negative 4, 10 to the negative fourth power. And this is how you write the number in scientific notation. Now let's take a big number like this one. How would we do this? Well, we already know that the decimal point is technically on the very right side of the number. Now let's keep moving it until we get a number that's in between 1 and 10. 1, 2, 3, 4, 5, 6, 7. And if we move it 7 times, we get 9.2. Now 9.2 is smaller than this number here. So it's going to be 10 to the 7th power because we moved the decimal point 7 times. So now we have another tip that we can use. If the decimal point is moved to the left, then the power is positive. And if the decimal point is moved to the right, then we know that it's to the negative power. Now, this last one is just a really big number. 1, 2, 3, 4, 5, 6, 7, 8. So if we move the decimal point 8 times, we'll get 4.5. This is in between 1 and 10. And we're going to multiply this by 10 to the negative 8 power. And so all of these three have been effectively written in scientific notation.